Use centered rectangles of width 0.5 to estimate the integral from 0 to 3 of e to the x dx, and then the integral from 0 to 3 of 5e to the x dx. So what we're looking at here is the integral from a to b of f of x dx. So essentially a times that being equal to the integral, I shouldn't use a because I've already used a at the bottom here, let's use some constant c, is equal to a to b of c times f of x dx. In other words, what we're showing here is a useful trick that we can slide a constant outside of an integral. Now, without spending too long on setup here, because we've seen it a few times, we're going from 0 to 3, rectangles of width 0.5, so we're going to need 6 of them. The first rectangle would be here, and then the second one here, and if they're centered, the heights of them are going to be at the middle. So the first one is going to be at 0.25, just like it was in the last example. The next one will be at 0.75, which is 0.25 plus 1 times 0.5, and then the next one over would be at 0.25 plus 2 times 0.5, which means we can set it up really nicely using the sigma notation on the calculator as we've done before. Now, I've already done it this time. So you can see that the top one here is part A, so that's on the left, and you can see the 0.25 plus y minus 1, 0.5 as the power of the e. The width of the rectangle is the 0.5. We've got 6 rectangles there, and it gives us 18.888. So let's just write that down. And then 5 times that is 94.441. And then just below, you can see that if I do 5 times the 18.888 answer, I get exactly the same answer as we have above, except for that very last decimal place there, but that will just be rounding on the calculator. So it appears that this is true from this example, and in fact it does generally apply